thus far, when we've been talking about individual states in a Markov chain, the first one we started talking about was absorbing. The next two we're going to discuss are kind of the opposite of that. One of them is transient and the other is a recurrent. All right. So the way we're going to start about discussing this is by what is a recurrent state. A recurrent state is any state that we're guaranteed to visit again. So let's give a quick example of that. So let's say we had these two Markov chains and they just flip back and forth. So with probability 1, you go to 2, and with probability 2, you go to 1. Now, in this case, we would say both state 1 and state 2 are recurrent because it is guaranteed that if you start off at 1, at some point in the future, you will return to 1. Likewise, for state 2, if you are in state 2, then it is guaranteed that you will come back to state 2. Now it ends up that we still have recurrence. Let's say we change this now to, let's say, 1/4 loop back, and then 3/4 go to 2, and maybe 1/2 and 1/2. In this case, what we'll also say is that 1 and 2 are recurrent states. Even though it's probabilistic, it is almost guaranteed that at some point, if you're at 1, you will get back to 1, right? And so that's the definition of recurrence. Now with a transient state, what we say in the case of a transient state is that the probability of returning is actually less than 1. So we can sort of set up an example of how that might happen. Let's say we have state 1, 2, and 3. And I'm going to make 3 an absorbing state. And I'll change this so 1/2 go from 2 to 3. And we'll keep the rest of the numbers more or less. So in this case, we know state 3 is absorbing. And what we're going to end up saying is that these are actually transient states. All right, why are they transient? Well, they're transient because we're not guaranteed that we return to them. So how might that happen? Well, let's say you start off in state 1, right? There's some chance that you go to state 2, and then there's some chance that you end up in state 3, and you can never get out of state 3. Because you can, once you get into state 3, you can't return to 1, we say that state 1 is a transient state. Likewise, state 2 is a transient state. All right. So notionally, this is the distinction between a transient state and a recurrent state. So what I'll do next is I'll provide some of the mathematical definition of what that means exactly. All right. So the way that we're going to do this is we're going to start with a random variable or just a variable. This is typically called an indicator function. That's why we call it with an n. And this indicator function is going to be equal to 1 or 0. Right? It's going to be equal to 1 if our random state at step n, if at step n we're in the state that we're discussing. So here, let's say we're doing some indicator variable for state I. All right? And if we're not in state I, then our indicator variable will be equal to 1. So what we're going to do here is we want to calculate how many times we're going to visit a state. Okay? So the way we do this is we just count how many times in is equal to 1. So let's say, so first let's start with the number of times we visit state I. Well, that's just going to be equal to I0 plus I1 plus I2 all the way out to infinity. Okay, so again, did we visit in time step 0? Did we visit in time step 1, 2, 3, 4, 5? Okay, now it makes sense with the recurrent state variable that if we add up I0, I1, I2, I3, okay, then what will happen is the sum of the i's from n equals 0 to infinity will actually equal infinity. So they will go to infinity. Okay. Now for a transient, the sum of 0 to infinity of I of n will actually be less than infinity. It will be a finite number. Okay? So let's take the next step. And we can actually calculate. So one useful thing to do is to calculate how many times do we expect to visit a particular state I. Okay? And so what we're talking about here is what we're going to say is we're going to take the sum from n equals 0 to infinity of I of n, okay, given, and what we're going to do is we're going to pretend that we started in that initial state I. So this is the value that we want to calculate. All right. So we can rewrite this expectation as a probability, because expectations are just a probability. And that probability is given by the summation of n equals 0 to infinity times the probability that x, sorry, I changed notation here, this should be 0. I use subscript, that the x at time step n is equal to I, given that x of 0 is equal to I. Okay. Now, the reason why we can do this is because what we're going to end up doing is, remember, the expectation of a random variable is just equal to the summation of x times the probability of that, right? So what we're multiplying by is times I of n, right? Which is either 0 or 1. All right? Now, this probability is 0 if I of n is 0. So it ends up that we can just sort of write it like that. All right, so that makes life a little bit easier. Because now all we're doing here is we're saying, well, what's the probability that we return to state I after 0 steps, 1 step, 2 steps, 3 steps, 4 steps, all right? So really what we're saying is, let's take the sum from 0 to infinity. Let's take our P matrix, raise it to the n power, and look at II. Because II is starting in state I and returning to state I. Okay. So another way that we can define recurrence or check for recurrence is we are recurrent if the summation of n equals 0 to infinity of our matrix to the n power, pulling out II, is equal to infinity. Okay. Or it's transient if the sum of that same matrix, right, or the P to the n matrix, we take the sum and we pull out the II value corresponding to the value we're interested in. This is less than infinity. Okay, so why do we use this equation and not that equation? Well, we use this equation because P is what we're given. Okay. So let's sort of look at what happens when we try to do this. So I'm going to, hopefully you'll try to remember. I'm going to erase this and hopefully you can figure it out. We can do a couple examples. Okay, so let's start by looking at this first guy right here. Okay, so our P matrix is 1/4, 3/4, and then we have 1/2, 1/2. Okay, so what I'm going to do is I'm going to ask, is state 1 recurrent? And is state 2 recurrent? Okay. So in this case, we know neither of these states are absorbing, right? And so really what we're asking here is are they recurrent or transient? Okay. So I'm going to switch over to Octave, and we're going to go through this calculation to get some intuitive sense of how it might work out for this example.